Hey guys, how is it? Hold on, I need to do something real quick. Oh, hashtag, that was awesome. Oh, sorry about that guys, I just really felt the need to take a selfie, or rather take a picture of myself. I even felt the need to do a hashtag where I put a hash before anything important I want to say. I'm just going with the flow. You know, the first person to actually ever use a hashtag and a selfie combined was Jennifer Lee, who used it on January 2011. Since then, it has been used over 75 million times, creating the social network as it is today, creating Facebook and Instagram as it is today. But what created our universe as it is today? Let's have a look at the holographic universe theory. Now, this theory was actually proposed by David Bohm, a colleague of Albert Einstein. Now, I'm sure you all know that the universe is three-dimensional. What this means is that, how about I give you an example? This Rubik's Cube has a height, it has a length, and it has a width. So that's what makes an object three-dimensional. And our universe already has all of these. So meaning our universe has to be a three-dimensional object. So keeping this in mind, let's have a look at some 3D art.
Take a look at this. This type of art piece looks three-dimensional. It's as if you're peering into the ground. However, I don't think I need to tell you that this art piece is in fact two-dimensional, in the sense that it has a length and a height, sort of like a square.
That is what the holographic universe theory is trying to prove, that our whole three-dimensional universe is just painted like the 3D art you saw before. It's just painted onto a cosmological flat surface. Now the reason why it's called holographic is because they believe that, or they're trying to prove, how the universe is projected onto a flat surface, as I said before. So physicists from the Epilogue University were trying to devise models out of this, yet there hasn't been much proof of this universe, or of this universe theory. So in other words, this theory is pretty much scrapped from the potential origins of our modern universe.
Let's have a look at my room. Yeah, I know, it's pretty messy. My mother claims that it has always been like this. Papers everywhere, stuff that isn't really sorted. But the universe can be thought of as one giant, messy room. Take a look at this picture of the universe. There's no organization, no uniformity. You have stars and galaxies just everywhere.
Similarly to my mother, the steady-state theory proposes that our universe has always been like this. Messy and unorganized, the structure hasn't changed, it's still the same from beginning to the end. For 13.7 billion years, our universe has always been like this. That's what Sir Thomas Gould, Sir Fred Hoyle, and Sir Hermann Bondi had proposed in the late 1940s. That our universe has always been like this from beginning to end. Of course, this theory, along with the holographic universe theory, was pretty much scrapped, and I'll tell you why it was crossed out from the potential origins of the universe. But there's another reason why the steady-state theory doesn't really work. But before I tell you why it doesn't work, let me draw your attention to another theory. Now, this theory is a very scientifically renowned theory, and a lot of people, a lot of cosmologists actually, are starting to believe in it. It's called the Big Bang Theory, and I know, you're probably thinking about the TV show starring Jim Parsons as Sheldon Cooper. But I'm sure you all know that the Big Bang Theory is an actual scientific theory that explains how the universe was so small that it was actually condensed all into a point, and in just in a fraction of a second, it just expanded to the likes that we've never seen before. Where did it expand from? Where did the universe come from? Well, as I just said right now, the universe came from a point, and this point is called the singularity. Now, what is the singularity? Well, we don't know. According to Khan Academy, it is a point that the maths just doesn't apply to. It's infinitely dense.
To give you guys an idea about the singularity, let me just draw it on paper for you. Okay, I've drawn it. Now can you see it? You can't? Exactly. That's how small the singularity is. That if I were to draw it on paper, it would be impossible for you to see it with the human eye alone. Now, why am I going crazy about this? Why am I raving about it? Why do I keep talking about the singularity? Well, that's because our whole massive universe came from a point that we can't even see.
To make matters more interesting, the universe is still expanding today. How do we know about this expansion? Well, the credit does go to Edwin Hubble, who proposed the Big Bang Theory in the 1920s. Hubble looked through one of his telescopes around the 1920s and he noticed something quite strange. All the stars and the galaxies started to move away from our observable universe, meaning it moved away from Earth. This means that the stars are moving away from us at a very systematic rate. So from this, Hubble theorized, so he thought that if the stars are moving away from us, then the universe had to be expanding. And then, if we were to reverse time, then there should have been a period where all the planets, the stars, the galaxies were all contained into a single point. But like every video on YouTube, there is always that one guy, one annoying guy, who for some reason will dislike your video. That annoying guy at the time was Albert Einstein. Except he actually had a reason to dislike, well, Edwin Hubble's theory. At the time when the Big Bang was announced, Einstein had already believed in the steady-state theory, and so he hoped that his general theory of relativity would sort of support his idea of a static universe. Ironically, what he actually did find was that after performing his calculations, he sort of found out that the universe either had to be contracting, or most importantly, expanding. However, as I said before, you can't use maths to prove a theory. The Big Bang Theory was a logical theory, but it didn't really have any physical proof. However, there were leads that we were beginning to find that led to evidence, to physical evidence of the Big Bang Theory. One of these leads was the cosmic microwave background, or the CMB for short. So how were we able to take a picture of the universe 380,000 years after the Big Bang if our universe is 14 billion years old currently? Well, the thing was, before the 380,000 year period, the universe was opaque, meaning all the light that was around that singularity, or that was just expanding out, was either blocked by the surrounding plasma or ionized gas. So no light could travel through the plasma, it was just reflected back. So it was at this time where atoms were starting to link up and form elements such as, or matter, such as hydrogen. And hydrogen was a transparent gas, so light could travel through this hydrogen and on through the universe. And as the universe expanded, the photons, or the light rays, just kept traveling for 13.7 billion years until hitting one of our detectors.
Now take this circle as the circumference of a sphere, the blue circle right here. This blue circle right here is the CMB, and also the universe at the 380,000 year mark. But then it started to expand to become the universe as it is today. This blue layer here is the universe, or rather the CMB, and this green layer here, is the universe today. Both of these layers exist, except the CMB, as it doesn't, the CMB, the blue layer right here, doesn't exist as a physical layer, but it exists as a layer of microwave radiation.
However, we were able to detect this light as microwaves, because this light just eventually became microwaves due to the fact that its wavelength the light's initial wavelengths started to expand a little bit to become microwaves. So it was because of this, and it was because of the early light of the universe that we were able to form this, well, baby picture of the universe, the 380,000 year picture of the universe. So in summary, the cosmic microwave background is the layer of leftover radiation that was left over from the early light of the universe that broke free of the surrounding plasma and traveled along with the expansion of the universe. Two scientists named Arne Penzias and Robert Wilson had actually discovered the CMB by accident in 1965. They found that they kept getting this annoying background noise, and so they tried cleaning their equipment for bird poop, but still they ended up getting the same background noise. And it wasn't later on until they discovered that what they actually found was the cosmic microwave background, or rather they were detecting the CMB. This is why the steady state theory is not true. See, the CMB is an indication of how our universe was at the 380,000 year mark. That goes against the principle of the steady state theory, which states that the universe from beginning to end was the same. But the CMB goes out against this, as it shows how there was no balance of density. Everywhere there was always this fluctuation in energy. So I hope you have an understanding of what the CMB is. Well, the universe expanded through the process of inflation. Now, the theory of inflation was proposed by Alan Guth in the 1980s. Now, keeping this in mind, Heisenberg, no, not Walter White, the actual scientist, had devised a principle called the uncertainty principle. This principle states that there are always going to be fluctuations in energy. You can't keep the level of energy in matter to an absolute zero. There's always going to be fluctuations. So when inflation occurred, the universe expanded very, very, very rapidly. It was even faster than the speed of light, to the likes of we've never seen before. You can consider inflation as the bang in the Big Bang Theory. And it was because of this inflation that there were ripples in space-time. You had masses just vibrating from the point of singularity to the universe today, giving off waves of energy such as gravity. Now, this is what I wanted to talk about. As I said before, the CMB is an indication of how the universe was 380,000 years after the Big Bang. And it was because of this inflation that there were ripples in space-time. You had masses just vibrating from the point of singularity to the universe today, giving off waves of energy such as gravity. Now, this is what I wanted to talk about. As I said before, the CMB is an indication of how the universe was 380,000 years after the Big Bang. So if we can study the CMB layer, then we can find indications to the origins of our modern universe. Now, when the singularity expanded, 4 forces are thought to have entered the universe: strong nuclear force, weak nuclear force, electromagnetism, and gravitational waves. Now, scientists were actually trying to look for gravitational waves on the cosmic microwave background, but in order to do this, they needed to take another image of the CMB. Now, polarization is just how the electromagnetic waves of an energy type such as light is oscillating. So, is it oscillating back and forth? Is it oscillating up and down? That kind of thing. So physicists were able to predict how gravitational waves would behave on the polarization on the cosmic microwave background by focusing more on the hot and cold spots. And that is what the BICEP 2 research team has found.
Now, this is an image of the cosmic microwave background radiation. And so the black lines here are polarizations, and the blue and the red spots are temperature spots of the CMB. So if you look over here and over here, you see swirly patterns, and this is what's meant to happen when gravitational waves vibrate through the CMB. Therefore, this shows evidence that gravitational waves had actually occurred on the CMB.
So does that mean that the Big Bang Theory is still a theory? Well, we do have physical evidence that inflation did occur, so doesn't that suggest that the expansion of the universe did actually happen? And that's what the Big Bang Theory suggests, the expansion of the universe. But, even though there is still too much to be figured out, we are now finding clues as to how our universe came to be as it is today. The universe or space is all around us. If you go out tonight and look at the night sky, you are staring at space itself. Unless it's a rainy morning and all you see is clouds. Nonetheless, we are living in the universe itself, and we are now finding clues and discovering new secrets as to how our universe came to be as it is today. Thank you all for watching.